So now we're going to use the same data tables to solve for K for this reaction. So it feels like we use these data tables for everything. And we do. We can figure out a lot of information just by running even only 2 experiments. So previously you saw where we were at this point and we had the rate law, and that's great. Now what we want to do, once we have the rate law, we can pick any experiment and this rate law will stay true. So I can pick like experiment 1, and I have a rate value, so this would have a value. I have an A value, so this would have a value. I already know my exponent, and so that means I only have one variable and I can solve for K. So that's what we're going to do next. All right, so we're just going to say rate is 8.6 times 10 to the minus 3, and I could have picked any experiment. I just happened to have picked this one, times 0.3, and that's raised to the 1, obviously. So I'm going to divide both sides by 0.3. And that cancels, so that'll be solving for K. And that gives me 8.6 e to the minus 3 divided by 0.3. So my K value for this reaction, and this is usually written in scientific notation, so 2. And you know what, it's kind of funny, I only have 1 sig fig here, and I really should have used 2. So let's pretend that I have 2 sig figs in here. So if I have 2 sig figs, I can at least say that that's 286, which rounds it up to being 2.9, times 10 to the minus, and if I like count over on my calculator, that's minus 2, and that's that K value. And again, that K is for any reaction, that's going to be the K value. I'm going to do the same thing for this one over here. So here's the rate for this one. Again, I can pick any experiment. I'm just going to grab the first one because why not? K, and then this is 2.0 squared. And so I'm going to divide both of these by 2.0 squared. And that'll cause my 2.0 to cancel out so that I can solve for K. And then I will just put in 1e to the minus 1 divided by 2 squared. I used my square key on that one. That tells me that in this case, again, scientific notation would be 2.5 times 10 to the minus 2. You're probably thinking, oh, you should have done 1.0 to give myself 2 sig figs. You are correct. But there we go. So it's not too hard to solve for K once you have the rate law and any single experiment. Note that a second way that this problem can be presented is without all of the experimental data. It could just say if a second order reaction has this rate and this concentration, what is K? So we have just jumped past the experiment because if it says it's second order, and it should also say like with 1 reactant, like it only has 1 reactant in it, then we can jump right to already knowing what is the rate law and then plugging in the rate information and plugging in the molarity information.